Hi class, it's me, Mr. Morris, and I wanted to go through a video real quick talking about two really common intensive physical properties. That's the reason we talk about it right now, is because you've just learned what an intensive physical property is, and you need to know that both of these are intensive physical properties. The first one is pretty simple, so that's why I start with it. It's called viscosity, and you don't need to know a lot about it, but I want you to know viscosity is an intensive physical property. That's very important. And then also I want you to kind of know what it is. Viscosity is a measure of how slowly a liquid flows, or often it's also a measure of how thick a liquid is. So if something has a high viscosity, if it's a high viscosity, that actually means it flows very slowly. And if it has a high viscosity, it also probably means it's a very thick liquid. The reason we're being so specific about this is because it can be kind of confusing to students sometimes if I ask you, well, this flows slowly, is that high or low viscosity? I want to make sure that you get that very, very clear. Okay. If something has a low viscosity, it's actually going to flow fast. You could say quickly, fast or quickly. It's probably a thin liquid. All right, I just zoomed my camera out so that I can show you guys a couple different substances, and we're going to compare their viscosity. So one of the substances is honey, and the other one is olive oil. So I've got a bottle of each right here, and what I want you to just notice is if I wiggle this a little bit, the olive oil, you can see where the liquid is. If I just move it, it's flowing very quickly and smoothly, right? If I do the same thing with the honey, it's taking a lot longer to flow from one location to another. So that's what I'm talking about when I talk about viscosity. See how the honey flows much more slowly? The thick substance is not all that runny, okay? So a runny substance that goes quickly when you pour it, and it's a thin substance, a thin liquid, that has a low viscosity comparatively. Okay, this is a lower viscosity. This is a higher viscosity because the honey flows more slowly. It's a thick substance. So that's just to give you kind of a context for viscosity. Let's look at some examples of it now. Let me adjust the camera real quick. And while we're on that note, let's skip down to our examples down here. Molasses, water, vinegar, and honey. We want to write down if they're high or low viscosity. So the ones that I know are a high viscosity or a low viscosity. Well, I know that honey, because I just messed with it a little bit. I know that's pretty thick, so that would be a high viscosity. And then water. Think about water. If you poured it, would it flow really slowly like honey, or would it just run all over the place? I hope you know that it's a pretty low viscosity. It flows very quickly. Vinegar is kind of like water, so I'd say low. And molasses is actually even thicker than honey. Some of you know what molasses is like, and maybe some of you haven't cooked as much, maybe you don't know. But molasses is a very thick substance, so we would say it has a high viscosity. Honey and molasses are the two examples you most commonly see, so you should probably know both of those have a high viscosity. All right, how does temperature affect it? Well, as the temperature increases, the viscosity decreases. Think about syrup. If you were to heat syrup up in the microwave, is it going to be more or less runny? Well, it would be more runny, so that would mean the viscosity went down. If it's more runny, it's a low viscosity. If it flows slowly, it's thick, that's a high viscosity. So as temperature decreases, that'll be the opposite. The viscosity will increase. Like if you put syrup in the refrigerator. Okay, and the difference in the viscosity at higher temperatures, the molecules are actually moving faster. We're going to spend a lot of time in this class talking about the differences that occur when molecules move faster or slower, especially in the gas laws unit. But this is the first time we really talk about that. Higher temperatures make the molecules move faster. Actually, I think we do talk about it a little bit in states of matter. We'll get into it more and more. All right, that's viscosity. Just know it's an intensive property that is a relationship. It's just telling us how slowly something flows. And then we get into density. Density is another intensive physical property, so you need to know that. And then we want to know what density is and be able to understand it and explain it. Why does oil seem to float on water? Think about that for a minute. And I hope that you can say, with relationship to density, you may know a little bit about density. It's because the oil is less dense than water is. And because of that, it floats on top. There are two things that can make one liquid less dense than another liquid. So one possible reason is because the mass of the particles, like we're talking about the molecules or something, the particles, is greater. So in other words, I'm telling you the mass increases. So as a result, the density increases. And the other reason is because the particles are closer together. So they're crammed in a smaller space. And what that means is that our volume has decreased. If they're in a closer space, the volume decreases. And if volume decreases, that also makes density increase. So density is actually a relationship between these two variables, between mass and volume. It is an intensive physical property. Don't miss that. It's an intensive physical property. And it gives us information about how tightly the atoms or the molecules in a substance are packed together. So with that, let's go on to look at some examples of how we can think through this. Why is it that solids tend to be more dense and gases tend to be less dense? Well, as the temperature increases, in matter, we see that the matter's volume increases. We go from solid to liquid to gas. So lower temperature up to the highest temperature. So if we assume that no mass is actually lost during the heating process, then the density has done what as I go from one state to the next? Well, they're spreading out, the volume's increasing, and as volume increases, density decreases. So the density has decreased going from solid to the gaseous state of matter. Matter in its solid state is normally the most dense. It's normally more dense than the liquid state, but there is one exception, and it's an important exception that we talk about a whole lot. It's water. Think about ice water. The solid state of matter floats on top, and remember that if it floats on top, that means it's less dense. So ice is actually, and if you could look at the molecular level, and we'll explain that a little bit more in pre-AP chemistry at least later on, why it is that ice is going to spread out this way, why the molecules orient in the way that they do. But here's what I want you to know. Why is it that ice is less dense than water, than liquid water? Well, it's because when water freezes, it expands. You probably know that if you ever put something in the freezer, like an ice tray, or if you tried to freeze a bottle of water or something, it spreads out, it expands, right? So in other words, the volume increases. And when the volume increases, the density decreases. The mass didn't change, just the volume. So if the volume increases, the density decreases. So ice floats on top of water because it is less dense. So remember, the least dense substance floats on top of the most dense substance. That's just kind of the qualitative explanation of the property of density and what it is. In the next video, I'm going to talk a little bit more about the formula and the math behind density.